Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Ifan bin Nazaruddin, metric number 1170269. So today I want to continue with my video presentation on industrial training program. My company is Department of Applied Physics at Faculty Science of Technology at University Kebangsaan Malaysia, under supervision of Supervisor Professor Madya Dr. Nur Adlika binti Ainul Anwar. So throughout the 18-week period, my industrial training was very fruitful. I'll be highlighting on 3 important contents, which will be starting on description of tasks and projects, challenges and solutions, and knowledge and skills that have been required. So the first one, the task and project during industrial training. I've performed research on mobile app development for astrophysics and using the S9 for space data reprocessing, data analysis of X-ray radiation of active galactic nuclei galaxies, and attending lectures of astrophysics. So on the first task, research on mobile app development for astrophysics. So there are 3 categories that I found. The first one is astrotourism, which is inspired by Dark Sky Organization, which this concept requires physical interactions, exposure to the wildlife and the night sky, but this app category requires to collaborate with tourism agencies. On the next category is digital tourism, which only require virtual and augmented reality or virtual reality, and another attract people about space facts based on users' habits. And the last category is stargazing map, which highlights the stars in the sky based on location and time, which is interactive guide with device and also have celestial event reminders. And the next task is using the S9 for space data reprocessing, which in short is false color images that can be created by opening any fixed image and then choose a color scheme from the color menu and then create representative color images that will produce the image. There are 2 types of image that can be produced. The first one is optical image and the second is using multi-wavelength image. So the steps are shown. The first one is opens a fixed image to present the first red channel and then adjust the red image as how you desire by changing the scale, either log or power or linear or other scales. Images and brightness and contrast will be adjusted also, and then zoom and recenter the image to adjust the focus of the sample, and then repeat for the next 2 channels, green and blue, and then readjust by reselecting the images. And then these are the samples that I've obtained. In the middle is the optical one and the others are multi-wavelength images. So the next task is data analysis of X-ray radiation of active galactic nuclei galaxies. First step is using Chandra database and Xiao, and the samples are obtained to the local computer and process the data using terminal commands. And the second step is focusing on the sample by creating a region using the S9 software to highlight the source of sample based on the coordinates. And the next step is to extract spectral data and graphing using Xiao to process data, and herself used to plot graph. And then the graph is obtained, then we repeat the same step for another observation ID and compare the graph. The last one is to report and discuss with the supervisor and the team of staffs. And the next task was attending lectures of astrophysics. So there's 3 topics that I've learned, which are stars and galaxies, cosmology, and observational astronomy, which are very, very informative and great for astronomy. The next highlight is challenges and solutions. The challenge is working from home due to faculty SOP since October of 2020. The solution is each student includes supervisor Dr. Adlika has to use their own device and internet via online platform meetings, either Zoom, Google Meets, or Microsoft Teams. So due to lack of face-to-face interaction, we can only use online platform to perform the workflow. Another challenge is not having a mentor face-to-face. If not for the current situation of ongoing pandemic, I would suggest a solution, having a mentor by the side to assist a new research assistant for project managing, and I prefer having face-to-face hands-on problem solving. The third highlight for this video is knowledge and skills acquired. The first one is running program via terminal commands. For NASA-based researchers, having a Macintosh or a Linux-based system is very beneficial. Thus, the software compatibility is at the best on these operating systems. This Linux-based system used because they could modify it to fit NASA's needs, which is the core ideas of Linux. So as you can see on the photo on the right is an example of a NASA observatory using Linux system. So Linux is very common using in NASA. The next skill is creating optical image from multiple frames using the S9, either using multi-wavelength or optical. And the next one is handling data from NASA server to local PC and then reprocess the data to perform data analysis. As you can see, the photo on below shows that if you combine the images, you have to use the red, green and blue according to the length of wavelength, according to the electromagnetic wave spectrum. So the next skill is Astronomy Lectures, which lessons include basics of astronomy, knowledge, stars, galaxies, cosmology, observational astronomy and life beyond Earth. And that's for the end of the video. Thank you to the team on UKM for giving me the great experience internship program to analyze the data remotely via internet and astrophysics knowledge to broaden. Great gratitude to supporting team Nabila, Izzat and supervisor Dr. Adlika for giving my opportunity in data analysis and radio astronomy and the basics of research in astrophysics in hardware skills and also software. That's all. Assalamualaikum.